Hi guys, so in this video we are going to solve the lead code question number 88, that is merge sorted array. It's an easy type question, and it's a very interesting question. It don't means it is easy, so it will be not occur in interviews. It's a famous interview question. If you see the company tags, there are a lot of companies that has asked this question, like big companies also: Google, Adobe, Netflix, Amazon, Microsoft, PayPal, Apple, Indeed, Meta, TikTok, Nvidia, Facebook. So this is a company favorite questions also. Mostly the easy questions are company's favorite questions to sort the to filter out the students, because the easy questions are smart questions, smart type questions. So let's see this question and let's see how can we solve this question. So let's read the question statement, what this question says and what we have to do. So we have given two integer arrays, nums1 and nums2, sorted in non-decreasing order. Sorted non-decreasing means in ascending order. In ascending order, small to big, and two integers m and n representing the number of elements in nums1 and nums2, not the size. So we have to merge nums1 and nums2 into a single array sorted in non-decreasing order. In ascending order, we have to merge, and the merge array will be in non-decreasing order. So the final sorted array should not be written by the function. So it's a void function. So we have to return nothing. We have to do the operations in this nums1, and we have to just return nothing. But instead be stored inside the array nums1. So we have to merge this array into nums1. The nums2 array should be merged in the nums1, and it should be sorted. To accommodate this, nums1 has a length of m plus n. So nums1 has a length of m plus n, where the first m elements denotes the element that should be merged. So these are the elements that is going to be merged with these nums2 elements, and the last 10 elements are set to 0. These elements are set to 0 and should be ignored. So we have to place the nums2 element in place of these zeros. Num2 has a length of n. So this is a length of n, and we have given the m value and n value. And the output array, you can see, after merging all both of these arrays, and the output is in merged. Output is merged and in the sorted in non-decreasing order. So let's see how can we solve that question. Before solve that question, if you can see, this is a n elements. If you can notice in this example, in this question, so nums1 and nums2 are already sorted. That's what the question says, merge sorted array. So nums1 and nums2 are already sorted. These m elements are sorted, these n elements are sorted. Okay, so means this m elements last element will always be the greater. From these n elements, the last element will always be the greater in this array, in the specific array. So what we have to do, if we compare somehow, and whichever the bigger it is, we replace the 0 by that number. So that's how the non-decreasing orders we can maintain. So then we compare again So let's start with the dry run. So first we check what is the last element of this m, from this m elements, and this last element of this num2. So 3 is greater than 6. No, it is not. So what we are going to do, we will replace this 0 by 6, and we will take a pointer for to know the place of these, how to track the location of these elements. So we will take 3 pointers. This is a 3 pointer based approach. So one pointer we will place here, I. It's the last element of the m elements, from the m elements, and a second pointer will be placed in the nums2 in the last element, and we have to replace the zeros, so we have to track the location of these zeros. So we will take a pointer k that will track the location of these zeros. On the basis of that, we will replace the zeros as our condition fulfills. So let's see the dry run first, and let's see how can we solve it. So this is the example. So we have to create three. So the first pointer we will place, it's the here, the last element of the m elements. So the location of this, so the I value will be initially the m minus 1, because the nums1 total size is m plus n, and we have the m elements, as you can see the question, where the first m elements denotes the element that should be merged. So these m elements, these three elements, the m value is 3, so these three elements should be merged with the nums2 values elements. So the ith index will be m minus 1, and we will place a second index j of the last element, that is j equal to n minus 1, and we will point one more pointer k to this last element of this nums1, that is set to 0. What will be the k value? It is total size is m plus n and minus 1, because we are following the 0 based indexing. So we have the track of these locations. So now we will write a condition. So we have to move backwards, because we are starting from the last elements of both the arrays, and we have to move k also backwards, because we are filling according to the greatest. As we find, we will replace the greatest value there. So the first condition, the condition, so the if condition will be, if nums1 of I is greater than nums2 of j, so then what we will do, it means 3 is greater than 6. It is not, so we will write this later. Else 3 is not greater than 6. Yeah, that's the condition we have. 3 is not greater than 6 right now. So what we will do, we will take the value, we will replace the kth element value, that is 0, to this 6. So the nums1 of k to nums2 of j, and we will point this, we will move this k and j element backwards. So k minus minus, j minus minus. So 3 is less than 6, so the 6 will come here, and j will come here, and k will come here. Is 3 is greater than 5? No. Then else condition hits, so the kth value will be 5 will come here, j will move backward, and k will move backward. Is 3 is greater than 2? Yes, 3 is greater than 2. So now what we will do? We will write nums1 of k. So the value will be nums1 of I. And we have to move the I pointer backwards now. K will go backwards also. So what will come here? In place of 0, the 3 will come here, and the I will go back, and k will also go back, and now k will point this 3. Now we will check, is 2 is greater than 2? 2 is greater than 2? No, 2 is not greater than 2. So the condition fails. Now we will replace this kth value, that is 3 for now, with this 2. And as you can see, now our j is less than 0. 0, 1, 2, that's the indexing. Now j is less than out of this array. That's our condition hits, and our while loop will stop. So what will be the while loop condition? So the while loop condition will be I is greater than equal to 0 and j is greater than equal to 0, because we are moving backwards. That's why this condition greater than equal to 0. So that's the, now as you can see, the output 1 2 2 3 5 6, 1 2 2 3 5 6. We have the same output. Now there are some special cases. What will happen? Let's say this is your nums1 array. It is like 6 7 8, and the nums2 is 3 4 5, and the remaining are zeros. So I will point here, k will point here, j will point here. Is I is greater than 5? Yes. So 8 will come here, k will move here, I will move here. Is 7 is greater than 5? Yes. So 7 will come here, and I will move here, and k also move here. 6 is greater than 5? Yes, 6 is greater than 5. As you can see, now I will move backward. Now our I is out of the loop, and our while loop stops. So the final array will become 6 7 8, 6 7 8. So that's not the correct answer. The correct answer will be 3 4 5 6 7 8. So whenever, now k is currently pointing here, right? Sorry, k will point here when this I move backwards. So when there is elements left in the nums2 array, we will simply fill these values simply by doing nums1 of k equal to nums2 of j. So what we will do, we will fill out the values. So 5 will move here, and k minus minus, k will come here, j will, we are simply filling the values. We are not checking anything. If there are elements left, and we simply filling the values, leftover values of the nums2 array, we are filling it inside the nums1. So that's the basic concept, basic strategy to solve this question. That's the optimal solution. So let's see in the LeetCode how we can solve this question. So let's see how can we solve this. So first let's create our 3 pointers. I will be m pointing to the m minus 1 initially, j will be n minus 1, and int k will be m plus n minus 1. While this loop I is greater than equal to 0 and j is greater than equal to 0, if nums1 of I is less than nums2 of j, what we have to do, so nums1 of k will be nums2 of j, and j will decrease, k will move backwards, else nums1 of k will be, so the nums1 of I is greater than nums2 of j. So I will move backward and k will move backward, and the extra part was fill out the remaining, out the leftovers of nums2 element. So while j is greater than equal to 0, nums1 of k equal to nums2 of j, j will move backward and k will move backward. That's it. That's the question number 88. Let's try to run it. Our test cases are passed. Let's try to submit it. It is accepted. Let's try to see the time complexity. And so I is moving m times and j is moving n times. So the time complexity of this will be O of m plus n. And for this loop, we are simply filling it out. We are not doing anything. So in the worst case, there can be n elements we have to fill out, but that's the worst case. We are not doing any extra step. For the space complexity, we are using only 3 pointers. We are not using the any extra space. So the space complexity will be O of 1. So thank you for watching this video. Make sure you like and subscribe and share. Let's see in the next video.